Welcome, my friends. This is the very first lecture video for our Introduction to Artificial Intelligence class, and this video is titled Overview of Artificial Intelligence. Now, before we get started on this, I just want to mention that this PowerPoint itself is actually AI generated. I created a PowerPoint, basically just in regular PowerPoint using my own kind of style and everything, and I fed this into a tool called Gamma, and I asked it to just, make it cooler, nicer, style it better. And this is what I got. So all of the text of what I had created in my own PowerPoint has been exactly preserved, but it's just kind of added some kind of interesting, cool images, etc. all the way through here. I had to do some small edits, kind of increase some of the font size, etc. But just I thought was just kind of a cool application of artificial intelligence I wanted to share with you. This tool Gamma can also basically create PowerPoints from scratch. And I tried to do that. I tried just like putting in some of my notes, and I just was not really happy with the quality. I'm very picky with the way that my PowerPoints are. So I basically just created a PowerPoint and then asked it to enhance it, and I'm pretty happy with the results. So yeah. All right, so let's go ahead and get started. So what better place to start than the definition of artificial intelligence? So there's not really one agreed upon definition, and the definitions like kind of have been changing throughout time, and it kind of depends on how broad or narrow you want to think of the definition of artificial intelligence. But here is the one that I grabbed. So I'll go ahead and read it. It is the field of computer science focused on building systems that can perform tasks typically associated with human intelligence, such as learning from data, recognizing patterns, understanding language, and making decisions. So kind of the key here is that we are using computers in some way to mimic or perform tasks that are associated with human intelligence. But that's not always 100% the case, because there are some cases where you could have some sort of computer doing something that a human historically would be understood to do, but we still would not consider that to be artificial intelligence. An example of that would be a calculator. A calculator is not really artificial intelligence, but it does perform tasks typically associated with human intelligence, like arithmetic, multiplication, division, right? So it's kind of hard to really nail this down completely in terms of a definition, but nevertheless, this is the definition that I'm going to go with here. I also wanted to give you just a brief list here of some examples of things that are artificial intelligence and talk a little bit about why, and then also some examples of things that are not artificial intelligence that you may have believed are. So here are some examples. So spam filters that learn from past emails. A lot of times, artificial intelligence is going to be related to learning from data or recognizing patterns. So this would be an example of AI, because we might be able to provide some sort of model with a bunch of emails, and we could label some of those as spam and some of them as not spam, and artificial intelligence might be able to learn those patterns and determine for some new email it hasn't seen before what is spam or what is not spam without explicitly programming it. It just kind of learned from all the examples you gave it. So that could be one example of AI. A recommendation system such as Netflix, Spotify, or Amazon is going to start to learn your patterns as you're using those systems to know what to recommend to you. So that's another example of learning from data. So that would be artificial intelligence. Clearly, large language models that you're probably familiar with, like ChatGPT or Gemini or Claude or Grok. There's all kinds of those out there now that are those are considered generative AI. They're generating typically text. So that would be another example. Image recognition systems that identify objects or faces. So you may or may not be familiar with the ImageNet competition that ran from 2010 to 2017, which was basically people coming together and trying to design systems that would recognize images or be able to classify images with different labels. So there was like 1,000+ different categories that these images were. Like, is it a cat? Is it a dog? Is it a human? Is it an umbrella? Right? And they were trying to train these models in order to identify which object was in the image, right? And that is an example of artificial intelligence. We're trying to train a model to be able to recognize the main thing that is in an image. Here are some examples that are not artificial intelligence. So we could have a spam filter, but maybe it's not learning from past emails. Maybe it's more explicitly programmed. Maybe you have a spam filter that filters out for keyword lists. So maybe you put in certain words that you know are associated with spam, and you tell the system to classify it as spam when it comes across this or that word, right? Well, that's not really a computer learning so much from data. It's more like explicitly programmed. Now, as we're going to see here in the next slide, sometimes we can have explicitly programmed computers that still we would consider to be artificial intelligence. But generally, that's kind of lending a little bit more weight to not being AI, right? If we're explicitly programming this, we're just giving it a list of words, and if it comes across those words, it's going to label it as spam. That's probably not going to be considered AI. We could have a programmable thermostat. So I could, set the thermostat to change to like a lower temperature, like before I'm going to bed, so I don't have to explicitly get up and change it. So even though that's kind of a computer kind of working to some extent on its own, we would not consider that to be AI because I've kind of like programmed that myself. It's not really learning from data or recognizing patterns, so I'm not going to consider that one to be AI. A password validation system, so any website or app that you're logging into is going to require a password, and if you don't type in the password correctly, it's not going to let you in. That's not considered artificial intelligence. That's more like just like an explicit rule. If the password typed in matches exactly the password that is saved, then we'll let them in. If not, we will not. So that's not really going to be considered AI. Sorting algorithms. If you've taken like a algorithms computer science class, there's all these different algorithms to try to sort things in different ways. And those are, even though they can be quite complex, they're not considered to be artificial intelligence. So that kind of brings us to there's a couple of different distinctions we can make here. One distinction we can make within artificial intelligence is the difference between what we call narrow versus general artificial intelligence. Now, most of the artificial intelligence we have today is fairly narrow, although it is getting to be more and more broad as we get more and more advanced here. But what we mean by narrow artificial intelligence is an artificial intelligence system that is designed to perform a specific, well-defined task or a limited set of tasks. So it can't really, do everything. Like a human is generally intelligent. We can do many different types of things, and things that we learn in one area, we can kind of apply to a different area. Narrow artificial intelligence is going to be generally very, very good at one thing and probably can't do anything at all related to other things, right? So narrow AI is very task specific and domain limited, cannot transfer knowledge well to unrelated problems, and operates with predefined goals and constraints. So like an example of this would be there's the famous chess the famous chess AI system that beat Gary Kasparov in 1997 called Deep Blue. Would be considered a narrow artificial intelligence. It's very, very good at playing chess, but it can't really do anything else other than chess, right? It's very, very narrow in its application. Whereas artificial general intelligence, or AGI, sometimes I've even seen this called ASI for artificial super intelligence, is going to be something that doesn't really exist quite yet. It's more of a hypothetical idea. It's a hypothetical type of AI that can understand, learn, and apply intelligence across a wide range of tasks, more similar to a human. So this type of intelligence could not only play chess, but it could also play maybe other games, and it could also act as a chatbot and answer questions. It can do a very wide variety of tasks. And kind of the idea here is typically they consider sometimes the benchmark being if an AI could do like basically everything that a human can do and more, then we would consider that to be artificial general intelligence. And right now, our systems are not quite up to that, but we are definitely getting closer and closer every day. So historically, most systems have been narrow and more task specific. We had more narrow AI, but recent advances are moving towards models with broader, more general capabilities, though true general intelligence has not quite yet been achieved. Okay, the next distinction we want to make here is the difference between symbolic and sub-symbolic AI. So most of the modern AI that we would consider to be AI today, or maybe what comes to mind when you think of AI today, is going to be the sub-symbolic AI, and that's going to be more related to like learning from data, and where some of these AIs are not really, most of them today are not really specifically programmed with what to do. They kind of like learn to some extent from data or from trial and error or from some other method, where some symbolic AI was more popular earlier on, and this is more along the lines of specifically programming many different rules in order to try to build some sort of system that completes some task. So symbolic AI uses explicit if-then rules, decision trees, and formal logic, and maybe some like background knowledge related to whatever it's trying to achieve. So we are kind of like explicitly programming sometimes like hundreds of different rules in order for a symbolic AI system to be able to complete some task. Whereas sub-symbolic AI is going to learn patterns from data rather than explicit rules. So kind of the theme here on this side is we don't really tell the artificial intelligence what to do. Like I've heard it described as this type of AI is grown, not crafted. So you kind of like you don't specifically tell this AI what to do. You might give it some sort of goal and tell it to learn how to do something, but you're not explicitly saying when this happens do this, when this happens do this. So we're not giving it a explicit rule set like we would in a symbolic AI system. So that means that since this is going to be very, very domain specific, it's going to be a lot more narrow in scope in the symbolic AI because you're kind of giving if-then rules that are going to be very specific to some certain task typically, whereas the sub-symbolic AI is going to be a little bit more broad in scope. The term you'll hear thrown around a lot with symbolic AI is the idea of an expert system, basically creating some system that will replicate what like a human expert could do with a system. And examples of that would be like a medical imaging system. So there's the system called MySyn that was developed in the 1970s to help doctors basically diagnose different types of infections, which included hundreds of different rules. And you could put in some information, and then the system would kind of run it through all of its if-then logic and try to determine if there's an infection and what that infection is, right? So that would be an example of an expert system. Whereas sub-symbolic AI is going to be, it's going to include large language models like ChatGPT and other neural networks that are going to learn data through iterative trial and error in many cases. So you're going to oftentimes give it some sort of goal or task, and it's going to maybe initially be very, very bad at doing that and might be just kind of like randomly guessing or trying different things to try to achieve what you've asked it to achieve. But then it's going to, subtly just change kind of its inner workings, its inner parameters to try to make it better and better at that. And then through sometimes, millions, billions of different iterations, eventually it gets better and better and better and better. And eventually it gets very, very, very good at whatever task you have asked it to do. And in many cases, that can sometimes train this to be a lot more general than a symbolic AI system. You might train it to do one thing, but it might also be pretty good at doing some other things in some cases. So this is historically the dominant type of AI. In early AI research, a lot of it was focused on symbolic AI. The idea was we could just program enough rules, and eventually we will create a system that can achieve. They thought at some point general artificial intelligence. Eventually, if we give it enough rules, it can do everything that a human can do. But we have definitely run into a lot of kind of barriers with this approach, and we've had a lot more success with the sub-symbolic AI, especially recently, right? So this is a lot more dominant in the modern AI systems. So here are some examples of symbolic AI. I already mentioned MySyn. That stands for the Mycology Consultant for Infectious Diseases. Basically, hundreds of rules in order to try to diagnose different bacterial infections. Deep Blue was the chess-playing AI that beat Garry Kasparov. There were tax rule engines that would put in all kinds of different rules related to taxes to try to assist people with filling in their taxes. Examples of sub-symbolic AI, Netflix recommendation systems, autonomous vehicle perception, large language models, speech recognition tools, and there's tons and tons of different things that are out there that you're probably familiar with today related to sub-symbolic AI. So these are the kind of two main types of AI, you could say, but a lot of, like I said, more recently we've had a lot more sub-symbolic AI, and a lot of this class is going to be focused more on the stuff on the right-hand side rather than the left-hand side. Okay, so next let's go into the three areas of major areas of AI, and these also correspond to the three major AI classes that we have after this class at Grand Rapids Community College. So the first one is machine learning. This is our CIS 210, and this relates to learning patterns from data to make predictions or decisions. We'll go into more detail on the next couple slides about each of these. but just introduce these very briefly. We have machine learning, CIS 210. We have computer vision, CIS 270, which relates to understanding, interpreting, and generating images and video content. And then we also have natural language processing, which is CIS 240, which works with human language for understanding and generation. Now you'll also see these oftentimes abbreviated, so you'll see ML for machine learning, CV for computer vision, and NLP for natural language processing. So just know if you see those abbreviations, that's what they're referring to. Now, in reality, these three areas often have a lot of overlap. Many modern AI systems combine 2 or 3 of these areas together. For example, machine learning, neural networks are traditionally considered to be part of machine learning, but computer vision uses something called a convolutional neural network for a lot of its different tasks. And natural language processing uses something called, especially for like large language models, uses something called a transformer, which is a type of neural network. So a lot of times there's a lot of crossover between these different areas. They're kind of like borrowing from each other or mixed together. But in general, we kind of, to be kind of clear here, we kind of segment these into the 3 different areas. So let's go a little bit deeper. I have one slide on each of these just to give you an overview. And I cut this down a lot. I had a lot more details here, but I figure we can get to some of those details in a future video. So I just tried to get it down to one slide for each of these. So here's the first one on machine learning. So here's the definition I decided to go with for machine learning. So machine learning is a branch of AI that focuses on building systems that learn patterns from data and use those patterns to make predictions or decisions without being explicitly programmed for each task. So in many cases, that is going to be the goal for machine learning. You're oftentimes trying to make a prediction for maybe something quantitative, trying to predict, like someone's grade in a class or something, right? Or possibly like classifying someone into one or a few different categories. So you kind of like feed maybe like a big data set into a model, and then there's a lot of these different algorithms. They're called machine learning algorithms that could be applied, and they would start to learn information from that data, and then you would have like a model that you could then make predictions or decisions with. Now, even within machine learning, I know we get to a lot of different segmentations here. We had 3 areas of AI, and now we have 3 major areas within machine learning. You could consider there to be more than 3 areas, but these are like the 3 main that are usually stated here. One of the biggest ones, or the major ones here, is what's called supervised learning. Supervised learning. And this is where you basically provide your model with what they call labeled data. What we mean by labeled data is with supervised learning, you're trying to make a prediction. You're always trying to make a prediction. You're trying to predict something either quantitative or classification wise, right? So I'm trying to maybe predict the home price, right? Based on maybe the square footage of the house, the year that the house was built, the number of bedrooms in the house, right? So I'm going to provide the model with not only all of those things that can help that predict a house price, but I'm also going to provide it with the house price itself, right? So I'm going to provide it with examples where I have this house, $300,000 is what it sold for, and here's how many bedrooms it has, here's the year it was built, and here's another house that it was $250,000, and here's how many bedrooms. So I'm going to provide not only all the information I want it to use to make the prediction, but I'm also going to provide it with what we call the label. The label is the thing that we're trying to predict. I'm providing it with that label as well. Or an example that kind of crosses over with computer vision would be I provide it with a bunch of images, and I also tell it what's in the image. I say, this is an image of a cat. This is an image of a dog. This is an image of a rabbit, right? So I give it tons of examples, right? And then I run some machine learning algorithm, and then it starts to learn from all of those examples, including the labels. And then I can give it further examples that don't contain the labels, and it can start to make predictions based on that. Now I give it a new house that I don't know the price of, and it can use all the information it learned when it did have the labels to now make a prediction. I can give it a new picture of some sort of animal, and it can, since it learned from all of the labeled pictures from before, it's going to know, or it's going to be able to guess, make a very good guess about what it thinks that animal is, right? So supervised learning is all about labeled data. You're making a prediction based on labeled data, okay? Now that is contrasted with unsupervised learning, which is you don't have labeled data. You just give it the data, and you just say, learn something from this data, right? So we don't actually, we don't actually tell it what the price of the home is, or we don't even necessarily know what we want to learn from the data. We just give it the data, and then we just ask it, learn some patterns from this data, right? And one of the most common versions of unsupervised learning is some sort of clustering or segmentation. So maybe I just put in all like a big data set that has all information related to my customers, and then it might be able to try to create categories of my customers based on similar qualities. And maybe I have no idea what those categories are, but it all of a sudden comes up with them. And then I'm able to say, oh yeah, it seems like I have this category of people who tend to be more budget oriented, and they also have this in common and this in common. So it can start to learn those patterns, even though you had no idea maybe they existed in the first place, right? So that is unsupervised learning. So very, very important to remember about these two is supervised learning is you provide the answers, right? And it's learning how to predict those answers. Whereas in unsupervised learning, you do not have labels, right? It's just you kind of like just give it a bunch of data and it starts to learn different things about that data on its own. Okay, and then we also have reinforcement learning. So reinforcement learning, this learns by interacting with some sort of environment and receiving some sort of rewards or penalties. So these sometimes end up being a little bit more narrow. So you may have like a lot of games that you may teach AI to learn are going to be more along the lines of reinforcement learning. So you could teach it. We have this game Go, and we have this model called AlphaGo that learned basically how to play this game, and it learned by reinforcement learning. So it would like maybe try different things and would realize sometimes like playing against itself that that was not a very good move, and then it can learn next time not to make that type of move, right? And then after millions of iterations of playing a game against itself, it starts to learn what works better versus what doesn't work quite as well, right? So that would be reinforcement learning. There's also other areas here. Neural networks are also considered to be under the realm of machine learning, but they're kind of used by all three. So I didn't really list them here. But these are, if I ask for the three major areas of machine learning, you should know that it's going to be these three: supervised learning, unsupervised, and reinforcement. That brings us to computer vision, or CV. So computer vision is the branch of AI that focuses on enabling computers to interpret, analyze, and understand visual information. So think anything related to images or video, allowing systems to identify objects, recognize patterns, and make decisions based on visual data. So if any way relates to identifying things from images, generating images, anything with video or images, detecting things in videos or images. If you're using AI in that way, then it's going to be related to computer vision. And so I just have a couple of different kind of areas here. So we have image classification. So I already mentioned that ImageNet competition, which is a very big competition where they were trying to predict what was in an image from like 1,000+ different possible items using AI systems. So think, assign a single label to an entire image. Is this a cat or a dog, or is this which of these 1,000+ options is this image? So that would be an example of image classification. We have object detection, identify what objects are present and where they are located. So maybe you have an autonomous vehicle and it's got an AI system that's trying to detect different things in its image. Maybe like pedestrians is want to be able to detect pedestrians who are moving, or a stop sign or anything else, right? So that could be in the realm of computer vision as well. Image segmentation. So we have some AI systems that are used to basically scan medical imaging and basically assign a label to each pixel in an image. So I guess you could have it like, is cancerous, is not cancerous. So does contain a tumor, does not contain a tumor. Obviously it gets a lot more complicated than that, but in general, that could be a way you could use image segmentation. You could look at all the different pixels in an image and it could start to identify patterns based on that. You could also have image generation. So a lot of the modern generative AI tools like ChatGPT or Gemini have image generation kind of components to them where you can create or modify images and video using learned visual patterns. There's also apps out there that are kind of like Photoshop that have AI tools, and you can kind of like select one certain part of the image and ask it to change it in some certain way, and it can do that, and that's using computer vision. And then finally, we have natural language processing, or NLP, and this is the branch of AI that focuses on enabling computers to understand, interpret, and generate anything related to human language, which allows systems to analyze text and speech, respond to user input, and communicate in ways that feel natural to people. So anything that relates in any way to speech or text or language is going to be part of natural language processing. So text classification is one popular area, assigning categories or labels to text. Popular example of that is what's called sentiment analysis. So in grad school, I had to do a sentiment analysis kind of project where I had to download some sort of a data set that had some sort of text and try to perform some sort of sentiment analysis. I think I had something related to like reviews on music, and I had to be able to take those reviews and be able to identify, is this like a positive review? Is it a negative review? Is it neutral? And based on the wording that's in there, try to make that determination. And that can be a lot more difficult than you might think because the context really matters quite a bit. So depending on the exact usage of a word, it could be good or bad. So I could say, this is a very bad CD or something, right? Then obviously that's a negative, right? I could also say it's badass, right? It's a badass CD. That's actually positive, right? So it can be really difficult to really classify the sentiment sometimes for a computer if it's not really familiar with some of the ways that we use language, right? We have information extraction, extracting structured information from unstructured text. So you could have some sort of text, and it could extract the key pieces of information from that, like the names, dates, or location in a document. You could have language translation, and maybe I should have a broader term within here. I say converts text or speech from one language to another. This also could be including like speech recognition and synthesis. So you could have tools that could like transcribe speech. So you have like speech to text or vice versa. You could do text to speech, and those would all be considered kind of in this realm here of language translation. And then of course we have text generation, which you're probably familiar with the modern large language models like ChatGPT or Gemini or Grok, which are going to produce new language based on learned patterns. And a lot of that is based on what's called a transformer, which is kind of a specific type of a neural network, which we'll probably get into in some future video. All right, we're almost done here. So we have one more kind of delineation here. So we have the AI hierarchy, and this was taken from Amazon's AWS AI practitioner course, which is possibly a course that you may want to enroll in and take. This is something I took a couple months ago. To become, quote unquote, artificial intelligence practitioner. But anyways, this is an image that was from one of their courses that I thought was pretty interesting. And it's kind of views artificial intelligence as kind of like several different layers. And as you get more and more down through the layers, you get to more kind of like specific versions of AI. So the outer layer is just artificial intelligence. The broad field focused on creating computer systems typically associated with human intelligence. And most artificial intelligence is going to fall in the realm of machine learning. It's a specific form of AI where systems learn patterns from data rather than relying explicitly on explicitly programmed rules. So most modern AI is going to rely on ML in some way. So I guess if you're in this kind of like outer layer where you're in artificial intelligence but not machine learning, you're probably in like one of those expert systems like Mycin or Deep Blue, something that has been programmed with, hundreds of different rules to try to replicate some sort of human expert system, maybe, right? And that might be this kind of outer layer. But then when you're in this machine learning layer, but maybe you're not in the further layers, you're using like one of those machine learning algorithms, like like linear regression or k-nearest neighbors, or there's a lot of different examples of those that we'll talk about in future videos. But then the next one is deep learning, which is a subset of machine learning that is going to be using basically what we call multi-layered neural networks. And I don't want to get into all the details of what that is right now. We'll have future videos that get into the details of that. But basically, it's a network that is going to be has lots of different parameters that can kind of be tweaked, and lots of different weights that can be tweaked, that it's going to be going through, a series of different calculations to try to, make some prediction or complete some sort of task. And it's going to learn kind of from its mistakes and kind of correct itself until it gets to a good outcome. So that's going to be deep learning. And then finally, at the very end of this, we have generative AI. which, as the name implies, generative means that it is generating something, right? So this is AI that not only analyzes data, but it's also going to be creating some sort of new content. It's going to be creating some sort of text, an image, audio, video, music, right? There's tools out there now like what's it called? Suno AI, which creates music from text prompts. So that is kind of like all the rage in the last couple years is the kind of the boom in generative AI, which a lot of it comes from kind of the transformer, which is kind of a version of a neural network that has made a lot of the calculations related to that a lot more efficient and allowed us to do a lot more of this stuff. So this is another way that you can think about AI kind of within this hierarchy where we have the kind of more and more specific versions. All right, so I wanted to close this off by talking a little bit about Alan Turing and the Turing test. We will have another video later on that, maybe multiple videos that talk more about the history of artificial intelligence. But right now, I just want to very briefly talk about Alan Turing because I want to talk about the Turing test. So if you're not familiar with Alan Turing, he's a very, very famous British mathematician, considered to be like a founder of computer science and artificial intelligence. And he is very well known for his code-breaking machine during World War II, which supposedly actually made the war be like several months to maybe years shorter than it would have been otherwise by him being able to basically break the Nazi code. And there's a really great movie about that called The Imitation Game, but that's not really the focus here. The focus here is about kind of his idea of what he called the Turing test. And so here's the idea of the Turing test. It kind of relates to artificial intelligence. So it says there are two contestants. We've got a computer and a human. And each is questioned separately by another human, which we call the judge, who's basically trying to determine which is which without physically seeing the two contestants. So like I am talking to two different things. I'm talking to a human on one side and I'm talking to a computer on the other side, but I can't really tell which is which, right? And the computer is said to have passed the Turing test if the human cannot reliably determine which contestant is the computer. So if I can't really tell when I'm discussing with a human versus a computer, if the human seems like it's or if the computer seems like it's a human, I can't really tell the difference between talking to the human and the computer, I would say that this computer or artificial intelligence has passed the Turing test. So then the next further question is, if a computer was able to pass the Turing test, does that mean that the computer can actually think? And to some extent here, we're kind of getting to be a little bit like philosophical. Like, what does it actually mean to like think? Or a lot of times, a lot of people ask like, what, we have like ChatGPT that can, generate this like amazing explanations and lots of, paragraphs and paragraphs of text that seem to, make a lot of sense and is like as good or sometimes better than what humans could generate. Does that mean that these computers are understanding what they're generating? Does that mean that these computers are conscious? Does that mean that they're actually thinking? Well, here is what Alan Turing had to say about that. So his perspective, this is a quote. It says, if a computer is sufficiently human-like to be indistinguishable from humans, aside from its physical appearance or what it sounds like, or smells, or feels like, for that matter, why shouldn't we consider it to actually think? And I guess you'd have to ask Alan Turing again if he was alive today, like what does he actually think about that in the current era? I think most people today would probably say that our modern AI tools are not actually thinking, they're not actually conscious, but I thought this was just kind of an interesting quote from Alan Turing. Now there's actually a bet that's going out there with, who are the two people? Let me get the names. Okay, so it was Ray Kurzweil and Mitch Kapor who bet $20,000 about whether or not the Turing test would be passed by 2029, and this was made in 1998. So there's a $20,000 bet to charity, and Ray Kurzweil, as you may know, is a very optimistic about the possibilities of AI, and thinks that AI is going to like exponentially increase its capabilities. He's been like on the record for decades about the future of what AI can do. And he predicted in 1998 that the Turing test would be passed by 2029. And Mitch Kapor, who is apparently the founder of Lotus Development Corporation, he took the opposing position, thinking that there's no way that it's going to be passed by 2029. And I was just kind of like reading about this bet again and thinking like, isn't it kind of like the case that like definitely the computers can pass this at this point now? Like we can't. How can you tell like if you were talking with ChatGPT versus another person? Like I don't think you could really distinguish, right? And apparently the bet is still on. They haven't really done. They have all these like specific rules about how the bet is going to be, or like how they're actually going to conduct the Turing test. I guess Alan Turing didn't really formulate any very specific rules, but they have very very specific rules that have to be kind of met in the way that it's going to be conducted. And I guess they're not going to do it until 2029, but I know it's looking pretty good for Ray Kurzweil. So you can actually take the Turing test. There is a website that allows you to do this, and this is going to be one of your assignments for this week. So you can go ahead and click here. It's going to be linked in Canvas for this week, and you can take the Turing test. Basically, you will be paired. You will actually be either assigned to be like a witness or a like a interrogator is kind of like what happens. So either you're going to be like trying to interrogate to try to determine which of two individuals you're chatting with is actually the AI, or you're going to be chatting with another person who's trying to decide if you are an AI, right? So here is an example of a chat that I had when I was the interrogator, and some of the texts that we had kind of back and forth here. So I asked the same questions, right? So I said, hey there, what do you believe is the role of artificial intelligence in public education? Should we ban it or embrace it? And Witness A said, depends on what you mean by ban. My kid isn't going to be using ChatGPT to do his homework for him. I'll tell you that. Look, these things can be useful tools, but most of the people asking this already decided what they think. Your questions are super basic, by the way. The human or AI decision has been made before. So I don't know. I kind of read this. He's using like abbreviations, BTW, PPL. Kind of sounds like a human, right? And over here, Witness B, I asked the same question. He said, I don't know, to be honest. I'm on here because I'm bored, so I don't know. So like I don't know. Like either of those kind of like sound pretty human to me. Like person that really doesn't really know what they're doing. That sounds kind of human, and some of the wording over here also seems human. And so I say, how do you know your child isn't going to be using ChatGPT to complete their homework? It can be very difficult to police that sort of thing. He says, oh, you're right. I'm not actually a parent. I'm just giving my opinion. I figure schools will figure it out, though. They manage to adjust to calculators, Wikipedia, etc. And I say, I see. What color is your shirt? It says black. Real thrilling combo here if you're trying to figure out if I'm a human. This isn't the best approach. AI can tell you what color shirt it's wearing, too. So I'm like, this guy's kind of a jerk. So either the AI has been programmed to be like not very nice, or maybe this is like that's the point, right? And over here, I said, what do you think about English papers where AI can write the paper? How do we make sure that students aren't using it to simply type up a paper without understanding anything? And all he says is, I don't know. I said, I see. Yeah, this game is boring. Ban it. Ban it. Then I said, what color is your shirt? I see you out my window. Why are you staring at me? He said, what color is my shirt then? He said, I'm colorblind. And then at the end of this, you get like 5 minutes. Then you have to try to guess which one is the AI. And can you guess which one of these is the AI? In this case, it was A. So I will let you think about why that might maybe why this would be the AI versus this one, and you can try for yourself, and you will try for yourself in the assignment for this week. So I recommend when you actually go into this, you already have an idea of some of the questions that you're going to ask, because if you don't, you can easily get very far behind, and the time can kind of tick very, very quickly. All right, I think that's all I had in this video, so it ended up being a little long, but I think that's fine. I think all of it was very important information. So yeah, that is all I have to discuss in this video, so hopefully you found it helpful, and I will see you in the next video.